Hi students, today I am going to teach important problems in limits chapter. In this chapter you will get to one or two problems in your CET examination. I will send formula list and time saving results to your WhatsApp group. Please write down. Now I start first problem. The value of limit x tends to 0 e to the power ax minus e to the power bx divided by x is. To solve this problem, since x approaches to 0, we substitute 0 in the place of x, we get e to the power ax minus e to the power bx divided by x. See, we substitute 0 in the place of x, we get the result e to the power a into 0 minus e to the power b into 0 divided by 0 is equals to e to the power a into 0 is 0, e to the power 0 is 1, minus e to the power b into 0 is 0, e to the power 0 is 1. 1 minus 1 divided by 0 is equals to 0 by 0. See, this is indeterminate form. See, now here we solve this type of problems. We use L'Hospital rule. See, L'Hospital rule states that L'Hospital rule, LH rule. See, L'Hospital rule states that limit x tends to a, f of x divided by g of x is equals to limit x tends to a, f dash of x divided by g dash of x. See, in this result, to solve this type of problems, we again, since x approaches to a, substitute a in the place of x, we get 0 by 0 form. We apply L'Hospital rule again. This implies this result, limit x tends to a, f double dash of x divided by g double dash of x. See, this process is continuous till we get a real number answer. Now here we apply, to solve the given results, we apply now L'Hospital rule to given result. Limit x tends to 0, derivative of e to the power ax minus e to the power bx divided by derivative of denominator. See, means derivative of f means f dash of x divided by derivative of denominator means g dash of x. Now here derivative of numerator, here we have e to the power ax minus e to the power bx divided by derivative of x. Now simplify derivative of this result, we get the limit x tends to 0, derivative of e to the power ax is e to the power ax into a, minus derivative of e to the power bx is e to the power bx into b whole divided by derivative of x is 1. See, now here substitute 0 in the place of x, we get the result e to the power a into 0, 0 into a, minus e to the power x is 0, b into 0 is 0 into b whole divided by 1 is equals to e to the power 0 is 1, 1 into a minus e to the power 0 is 1, 1 into b is b divided by 1 means a minus b. A minus b is the correct answer. See, here we have a minus b is option B. Option B is correct result. See, next example. Limit x tends to 0, log of 1 plus x divided by 3 to the power x minus 1 is equals to. See, to solve this problem, since x approaches to 0, we substitute in the place of x is 0. We get limit x tends to 0, this is given result, log of 1 plus x divided by 3 to the power x minus 1. See, we substitute 0 in the place of x, we get log of 1 plus 0 base e divided by 3 to the power 0 minus 1. See, log 1 plus 0 is 1. Log 1 divided by 3 to the power 0 is 1. 1 minus 1 is equals to log 1 is 0 divided by 1 minus 1 is 0. This is 0 by 0 form. Indeterminate result. See, here we get indeterminate form 0 by 0 or infinity by infinity form. Here we apply L'Hospital rule. See, here we apply L'Hospital rule for given result. Limit x tends to 0. Derivative of this result, derivative of numerator d by dx of log of 1 plus x divided by d by dx of 3 to the power x minus 1 is equals to limit x tends to 0. Derivative of log is 1 divided by x form. Now here we have 1 plus x. 1 divided by 1 plus x into derivative of 1 plus x is 1 is 0, x is 1. We get same result, 1 by 1 plus x divided by derivative of 3 to the power x minus 1. Derivative of a to the power x result. 3 to the power x can be written as 3 to the power x into log 3 into derivative of x is 1 minus constant term is 0. See, now here also we substitute 0 in the place of x, we get the result 1 divided by 1 plus 0 divided by 3 to the power 0 into log 3. See, this result is equals to 1 divided by 1 plus 0 is 1, 1 divided by 1 is 1, divided by 3 to the power 0 is 1, 1 into log 3. See, base e. Log 3 base e. See, now here this result can also be written as log e base 3. See, now this is required solution. Option E is not possible, 0. Option C is correct. See, next example, the limit x tends to 0, 2 by x into log of 1 plus x. Limit x tends to 0, x approaches to 0, 2 by x into log of 1 plus x is, see, now here we substitute 0 in the place of x, we get 2 by 0 log of 1 plus 0 is equals to 2 into log 1 divided by 0. Log 1 is 0, 0 into 2 is 0, 0 by 0, indeterminate form. See, here we get indeterminate form. We apply L'Hospital rule. See, here we apply L'Hospital rule, limit x tends to 0, derivative of numerator divided by derivative of denominator. 2 into derivative of numerator, log of 1 plus x is 1 divided by 1 plus x divided by derivative of x is 1. Then substitute 0 in the place of x, we get 2 into 1 divided by 1 plus 0 divided by 1 is equals to 2 into 1 plus 0 is 1, 1 divided by 1 is 1, 2 into 1 divided by 1 is equals to 2. 2 is the correct answer, option C. So we try next example. Limit x tends to 1, x approaches to 1, 1 minus x tan of pi by 2x. See, in this result, we substitute 1 in the place of x, we get 1 minus 1 into tan of pi by 2 into 1, means pi by 2. 1 minus 1 is 0 into tan of pi by 2 is undefined result is infinity. Suppose we get in this form 0 into infinity or infinity into 0 or infinity into infinity form results. See, this type of results we convert into 0 by 0 form or infinity by infinity form. Now check this result. Here we have limit x tends to 1, 1 minus x as it is, right? Now here tan of pi by 2x can also be written as 1 by cot. 1 by cot of pi by 2x. 1 minus x divided by, or write directly this result, 1 minus x by cot of pi by 2x. Now, to solve this result, again, see, since x approaches to 1, means here we substitute 1 in the place of x. See here, 1 minus 1, you can write directly 0, no need to write all the steps. Then, now 1 substitute in the place of x denominator, we get cot of 90. Cot 90 is 0. See here we get indeterminate form, 0 by 0. See, we get indeterminate form, apply L'Hospital rule. See, L'Hospital rule in this result, derivative of numerator, 1 is 0, constant term, minus, see here, derivative of 1 minus x divided by derivative of cot of pi by 2x. This is L'Hospital rule statement form, is equals to, here we get limit x tends to 1, derivative of 1 is 0, derivative of x is 1, here we get 0 minus 1 divided by, divided by derivative of cot is minus cosecant square pi by 2 x into derivative of pi by 2 x, here we get pi by 2, derivative of x is 1. See, now here this result can be written as the limit x tends to 1 minus 1 divided by, minus, see here minus minus is cancelled, can write directly 1 divided by cosecant square of pi by 2 x into pi by 2, or you can write 2 by pi. Now here, since x approaches to 1 means we substitute 1 in the place of x, then this result becomes 1 by cosecant square of 0. See here, cosecant square of, see here not 0, here substitute in the place of x is 1, substitute 1 in the place of x, we get pi by 2. Cosecant square of pi by 2 is 1 into pi by 2 is equals to pi by 2 denominator. This result can be written as 2 divided by pi. Option B is the correct solution. So next example, limit x tends to 0, x approaches to 0, a to the power sin x minus 1 divided by b to the power sin x minus 1. To solve this example, since x approaches to 0, we substitute 0 in the place of x. This result becomes a to the power sin of 0 minus 1 divided by b to the power sin of 0 minus 1 is equals to a to the power sin of 0 is 0 minus 1 divided by b to the power 0 minus 1 is equals to a to the power 0 is 1, 1 minus 1 divided by 1 minus 1 is equals to 0 by 0 form, indeterminate form. See, now apply L'Hospital rule. Limit x tends to 0, derivative of numerator, derivative of a to the power x form. Here we have a to the power sin x. Derivative of the result is a to the power sin x into log a into derivative of sin x is cos x minus derivative of 1 is 0 divided by b to the power sin x into log b into derivative of sin x is cos x. Second term, derivative of 1 is 0, no need to write the result. Next to here, observe here cos x, here we have cos x, same term, this result is cancelled. Next, directly here we substitute 0 in the place of x, we get the result. Otherwise I write one more step, limit x tends to 0, a to the power sin x log a divided by b to the power sin x log b. See here we sub x approaches to 0. So substitute 0 in place of x, we get a to the power sin of 0, you can into log a divided by b to the power sin of 0 into log b. See, a to the power sine of 0 is 0, a to the power 0 is 1, 1 into log a is log a, divided by b to the power sine of 0 is 0, b to the power 0 is 1, 1 into log b is log b. Log a divided by log b is option A is correct. So to solve this result, the limit x tends to 0, e to the power x minus 1 divided by x. We substitute 0 in the place of x. E to the power 0 minus 1 divided by 0 is 1 minus 1 divided by 0. E to the power 0 is 1 minus 1. 1 minus 1 is 0 divided by 0 form. So this is indeterminate form. Here we can apply L'Hospital rule. Limit x tends to 0. Derivative of e to the power x minus 1 is e to the power x, derivative of minus 1 is constant term is 0, divided by derivative of x is 1. Here again x approaches to 0 means substitute 0 in the place of x. We get e to the power 0 divided by 1 is e to the power 0 is equals to e to the power 0 is 1. Option B is correct. See, here we have the example. The value of limit x tends to 0, x approaches to 0, 5 to the power x minus 5 to the power minus x divided by 2x. Since x approaches to 0, we substitute 0 in the place of x. We get 5 to the power 0 minus 5 to the power minus 0 means we get 0 divided by 2 into 0. See, 5 to the power 0 is 1. 1 minus 1 divided by 0 is equals to 0 by 0 form, means indeterminate form. Now here apply L'Hospital rule. Limit x tends to 0. 5 to the power x is 5 to the power x into log 5. Derivative of x is 1 minus 5 to the power minus x into log of 5. Derivative of minus x is we get minus 1. Minus into minus plus, divided by 2 into derivative of x is 1. See, here we substitute 0 in the place of x. We get the result 5 to the power 0 log 5 plus 5 to the power minus 0 or 0 log 5 divided by 2. See, 5 to the power 0 is 1. 1 into log 5. Log 5 plus 5 to the power 0 is 1. 1 into log 5 is log 5 divided by 2 is equals to log 5 plus log 5 is 2 log 5 divided by 2. 2 is cancelled. We get log 5. Answer, say option B is correct. So we try next example. See, limit x approaches to 0, tan x minus sine x, tan x minus sine x, tan x minus sine x divided by x cube. See, substitute 0 in the place of x, we get the result tan of 0 minus sine of 0 divided by 0 cube, means tan of 0 is 0 minus sine of 0 is also 0, 0 divided by 0 cube is 0, 0 by 0, indeterminate form. Here we apply L'Hospital rule. Limit x tends to 0. Derivative of tan x secant square x minus derivative of sin x is cos x whole divided by derivative of x cube is 3x square. See, now here we substitute 0 in the place of x, we get the result secant square of 0, secant of 0 is 1, 1 square is 1 minus cos of 0 is 1 divided by 3 into 0 square is 0, or 3 into 0 is 0 divided by 0. Again we get 0 by 0 indeterminate form. Apply L'Hospital rule. Limit x tends to 0. See, L'Hospital rule states that derivative of numerator derivative of denominator separately. See, derivative of secant square x is 2 secant x into derivative of secant x is secant x into tan x. Secant x into secant x is secant square x into tan x minus derivative of cos x is minus sin x, minus into minus plus sin x divided by 3 into derivative of x square is 2x. See, now here split this term, each term divided by denominator value, because see, we know the result tan x by x is a standard result. Limit x tends to 0, tan x by x is 1. Similarly, sin x by x is also 1. Say limit x tends to 0, sin x by x or x by sin x is equals to 1. That is using a sandwich derivation. We know that result. Now here we have the result tan x by x, here also sin x by x notation. That's why split this result, each term divided by denominator. This result can balance. This result is equals to limit x tends to 0. Therefore, this result balance, each term is 2 is cancelled. Secant square x by 2, I split this term, into tan x by x plus sin x divided by 6x. Limit x tends to 0, 1 by 6 into sin x divided by x. Now here x, see here, substitute 0 in the place of x, we get the result. Secant of 0 is 1, 1 square is 1 divided by 2, 1 by 2 into this result, limit x tends to 0, tan x by x value is 1 into 1 plus x tends, see here x approaches to 0, this whole term becomes 1, 1 into 1 by 6, 1 by 6 into 1 is equals to, see here 1 by 2 into 1 is 1 by 2, 1 by 2 into 1 by 6 into 1 is 1 by 6. Now take LCM, 6, here you consider 2 3s are 6, here 3 plus 1 is equals to 4 by 6, 2 2s are 2 3s are is equals to 2 divided by 3. So required solution, see here observe options, option see here a small correction, here 2 is cancelled, here we get 3 not 2, here 3, that's why here consider 3 not 2, because 2 is cancelled, that's why we can't get the result. Next here take LCM, you see here we get 2 plus 1 is 3 divided by 6 is equals to 3 1s are 3 2s are 1 by 2, not 2 by 3. See here option A is correct. See small correction, see here 2 is cancelled, we get remaining term is the denominator 3 secant square x divided by 3 tan x divided by x plus remaining term sin x divided by 6x. Okay, 1 by 2 is correct result. Now option A is the required result. See, to solve this example, limit x tends to 0, here we have x into e to the power x minus sin x divided by x, x approaches to 0. Now observe this result, each term here x into e to the power x divided minus sin x divided by whole term divided by x, here each term divided by denominator. See here we have numerator, this result becomes limit x tends to 0, x is cancelled, here we get e to the power x in first term, next to minus sin x divided by x, you can apply limit here also, limit x tends to 0, sin x divided by x, we are using algebraic property. See here limit x tends to 0, f of x minus limit x tends to 0, g of x notation form. Now here x, here we have to substitute 0 in the place of x, we get the result right here e to the power 0 minus, we know the standard result, limit x approaches to 0, sin x by x is 1. Say is equals to e to the power 0 is 1 minus 1 is equals to 0. See option A is correct. See the value of limit x approaches to infinity, sin x by x is. See, to solve this result, since x approaches to infinity, sin x divided by x. So we substitute infinity in the place of x, we get a sine of infinity divided by infinity. See, I split this term, limit x tends to infinity, 1 by x into sin x. See, x approaches to infinity, substitute infinity in the place of x, 1 by infinity is 0. 0 into, substitute infinity in the place of x, we get sine of infinity, a finite quantity less than 1. A finite quantity, sine of infinity is a finite quantity that value is less than 1. 0 into the term is 0. See, option B. Thank you, students. I will continue in the next video.